So hello everyone, my name is Yogesh and I'm going to talk about Ultralytics YOLO. So have you ever wondered how a self-driving car spots a pedestrian or how a security camera detects an intruder? One of the key technologies behind this magic is computer vision algorithm called YOLO, which stands for You Only Look Once. In simple terms, YOLO is super fast an efficient way for computer to identify and locate objects within an image or a video. So beyond recognition, YOLO is popularly used for detection, classification and segmentation. So in my first slide, I have presented the differences between the classification, detection and segmentation. We'll also be discussing this on the later chapters. So YOLO, it can be used in anywhere. So if I talk about the construction waste management, YOLO can be used to handle and monitor the construction and demolition waste that is produced in these construction sectors. So imagine a conveyor belt which is laden with a mixed construction and demolition waste. YOLO can identify materials like wood, concrete and metal in real time. Yes, in real time. And our this pilot program successfully has identified 95% of recyclable in one discharge. So let's discuss how this model works. So this is an open source library for AI tasks and it can be available and it can be easily obtained, or you can use the GitHub repository to run this model. So if you go to the Google and search for YOLO in the internet, you can find the repository. It is widely used in many tasks for the computer vision, including detection, segmentation, and classification. YOLO is popularly known for its simple API and used for model training, prediction, and validation. So let's start with our first chapter model. So welcome to the first chapter of the Ultralytics tutorial, and we are going to start with a very core concept, the model. So think of a model in Ultralytics as the brain of your AI system. It is a highly trained expert that knows how to look at images and understand what is in them. Just like you might hire a specialized expert for a task, like you can see these birds in the photo. So it can identify which kind of birds or which birds are present, and you use an AI model for tasks like finding objects, recognizing faces, even classifying the pictures by using these models. The main way you interact with these expert brains in analytics is through YOLO class. So you can see the YOLO class here. Even though there are different kinds of models, like different types of experts in our human field, this YOLO class, which we can see here, provides a simple way to load and use many of them, especially the popular YOLO series. So our goal in this chapter is to understand what the model is and how to use it. As I mentioned, for the most basic job, that is making predictions on an image. So let's look, okay, let's imagine you have a picture of a street with cars and people, and you want the AI expert, the model, to tell you where the cars and people are. This is called the object detection. So you are just detecting about the people and the cars. So this is, as I mentioned, called the object detection. So for example, there are people and car, and by using the YOLO models or the computer vision, you can detect which is a human being, which is cars and all. So in this Ultralytics, we are using this YOLO class. This is quite simple. You first need to get a pre-trained expert brain. So Ultralytics provide many of these ready to use brains like .pt files as mentioned here. YOLO for B8 and .pt. So it is a common starting point. As it is shown, it is a simple and a fast model. And think of these as the experts knowledge package. Okay, so here is how we can load one and ask it to look at your image. So for example, by using the Python, you can use the Analytics library to import YOLO. Then this is a pretend YOLO model export, and by using this .pt, which is the export, you can start that. This is where you hire your export. You are creating a YOLO object, we call it a model, and you are telling it to load the knowledge from this file. This file contains the pretend words of YOLO version 8. You can say 8, and the latest is 11 or 12 as well. This is from the YOLO version 8 nano model. It is taking that pretend words, and which is for to detect the objects later. And now you are just asking your export to look at this image. And so for example, now you are giving the image to detect. For example, you can give this image to detect. Okay, and after it will analyze the model, and you pass the path to your image file as shown in this .jpg file. And as it is a function, all right, as it a function, you are calling the model function, like a model function you are calling it, and this will process the image and it gives you back the results of the analysis. So what are the results? For object detection, the results, it can contain information about what the model found. It's like where the objects are in the image, what type of object they are, like they are a car or they are a person, and how confident the expert is about its findings. For example, the probability, whether it is 100% probable or to become a human, or it is just a 90% or something like that. So we'll be discussing these results in more detail in the later chapter called results in chapter 8. So for now, we just look the simple pattern. We load the model, we run it on data, which is a fundamental to using the analytics for the predictions. So what is really inside the model? So when you create a YOLO object by loading .pt file, as mentioned earlier, you are essentially loading the complex mathematical structure and the trained knowledge, that is words that make up the AI model. So different models are trained for different tasks. So for example, some are for the segmentation, some are for detection, like and while one is good at drawing outlines around the objects, other are good at recognizing what is an entire image, that is classification. Some only find the objects like whether it is car or people, and some can even find the joints on a body, which will be discussed in the results section, like post, which is a pose estimation. This YOLO class is designed to handle various types of YOLO models capable of different tasks. So under the hood, when we call that from the YOLO model file.pt, which is a weight or export knowledge backup, Analytics will figure out what kind of model is that file. Is it for a detection or segmentation, and on that basis it will set up the expert brain accordingly. So if we visualize the simple prediction process, we can see how the function works. So here is a user giving the running the script, and Python in a Python script which is calling the YOLO function, as we see in the previous example. And YOLO class will use different examples, like it will run the process the model pt load this file, and which will be return the model data, which will later run or which will be passed in the this which will create AI model export by using the AI model instance, and this process would run, this iteration would run for the analysis. Result will finally the result will find the return the findings, which will be later converted to those results, which can be viewable in human eyes. So this diagram shows that YOLO class acts as an intermediary. It loads the brain structure and knowledge from this model file.pt and creates an active AI model instance, like AI model instance to create. So and then when you give the instance an image file.jpg, when you read that image .jpg, when you call the model with this image, it will process, because it has that previous experience, therefore now when it see the image, it will process it, and it gives back the result. This core structure of the model's brain is defined internally, like analytics uses classes like detection model, segmentation model, which inherit from a base model. These are the blueprints for how the expert brain is built for different tasks. So you can we can also see the references in the code which is available in the GitHub. For a beginner, we don't need to worry too much about these internal blueprints. The YOLO class, now we understand that it handles loading the correct one for us based on .pt file which we provide. Okay, so let's move to the next slide. Here we can see the model we run. We are similarly running this YOLO 8x.pet file. So before it was n nano, now it is x, which means extra large. So each PT file corresponds to the specific trained expert brain. This YOLO function classes or YOLO class is smart enough to understand these functions. So this is the end of the first chapter. So before starting chapter 2, let me conclude. So we learned that the model in the analytics is the AI expert, the brain, which is represented primarily by YOLO class, YOLO, YOLO class, and we saw how to load a pre-trained model using model name .pt, and how to use it to make the prediction on an image by simply calling the model object like results. We use the results function here. We use the results function. So while the YOLO class handles the complexity under the hood, understanding that you are loading a specialized expert the model for a specific task like detection is a key. So now that we know how to use a pre-trained expert, right? What if we need an expert trained specifically for your unique type of images and objects? For that you will need a data. In the next chapter we will explore. In this chapter we will explore the concept of dataset, which is essential for training your own custom AI experts.